So in the previous videos, we have seen the meaning of limits, how to check whether the limit exists, to see the left-hand side limit, right-hand side limit. And we also saw a couple of ways in which we can evaluate limits, was factorizing the numerator denominator when it was a polynomial. We have seen rationalizing, and here we have another type. So this is one of the easier type to identify. So I'll take one question, question number 2. This is limits x tends to 3. It is x raised to 5. This is 243. And you have x square minus 9. So what you're supposed to do in this is x raised to 5. This is 3 raised to 5, x raised to 2, and 3 raised to 2. And then you can directly apply. This will be 5 upon 2 and 3 raised to 5 minus 2. So this will give you the answer 3 cube. So that will be 5 into 27 over 2. So 135 upon 2 will be the answer. So this should be expected as a multiple choice question where the answer can be marked easily by observing. So it is application of the first form. Only thing we have to check whether this is possible. So 27, can this be written as 9 raised to 3 by 2? So this is 9 raised to half raised to 3. And 9 raised to half is square root of 9, that is 3. And cube of 3 is 27. So that is true. So then we can directly apply the formula. Or first we need to write it like this. So that will be 3 by 2. 9 raised to 3 by 2 minus 1. So that will be 9 raised to half. So 3 by 2 into 3, 9 by 2 will be the answer. So I'll just write the formula one more time. Here you have limit x tends to a, x raised to n, a raised to n, and x minus a. So the point is that this is x, this is a, and this is x minus a. So in place of x, you have x plus 2. In place of a, you have a plus 2. So I can write this in the following way. You know that when you open it, you will get x minus a. So this is like that formula, and we can apply the property directly. And this will be a plus 2, 3 by 2 minus 1. So this is 3 root a plus 2 upon 2. So you get 4. So a raised to 4 is 81. The powers are equal. We equate the base. So a is equal to 3. We get that. When you look at the function of 1 upon x, it is a reciprocal function. The graph looks like this. So this is x and this is y. Okay, so as x tends to infinity, where is the function heading? And the answer is 0. So f of x tends to 0. And that same thing happens on the other side as well. So this is x tends to infinity. So how do we write it? We write limits x tends to infinity, 1 upon x, the answer is 0. Okay, so we are going to use this property in this particular exercise. And the rule is divide the numerator and denominator by the maximum power of x. And once we are done with few sums, I will tell you a property, how to identify certain things. So limit x tends to infinity. This is 4x minus 3. This is 2x plus 7. So if you ask which is the maximum power of x, the answer is 1. Like x raised to 1. Yeah. So therefore, you get limit x tends to infinity. So this is 4x minus 3 upon x. This is 2x plus 7 upon x. Limit x tends to infinity, 4 minus 3 over x, 2 plus 7 over x. Taking the limit 4 minus 0, 2 plus 0, the answer is 2. So in this question, it was a linear equation. The maximum power of x was 1. Now let's go to the second question. Again, the question, maximum power of x is 2. So therefore, divide numerator and denominator by x squared. So you have 3x squared. This is 2x minus 5 upon x squared. And you have x squared 5x plus 1 upon x squared. So the answer, this will be 3x squared plus 2 upon x and 5 upon x squared. 1 plus 5 upon x and 1 upon x squared. So when we take the limit, taking the limit, you get 3 plus 0 minus 0, 1 plus 0 plus 0. Answer is 3. Now, what I would like you to remember is you have a numerator which is, say, a raised to m, x raised to m, plus a raised to, say, m minus 1, x raised to m minus 1, and so on, and a raised to 0. And you have b raised to n, x raised to n, b raised to n minus 1, x raised to n minus 1, and so on. So what I want you to remember is this is how the polynomial are. Okay, where a raised to m is the coefficient of the polynomial. A raised to m is the coefficient. Like over here, what is our m? Our m is equal to 2 in this case. And what is our a raised to m? A raised to m is 3. In this case, what is our n? N is 2. And what is b raised to n, or bn, sorry, that is 1. If m is equal to n, like it happens in this particular case, m and n are equal, what does that leave you with the answer? The answer is the coefficient of the first term. Okay, so in our case, m equal to n was 2, and ambn is 3 upon 1. The answer is 3. So in case of a multiple choice question, you don't need to do all the steps. You have to arrive at the answer. So what you need to look, it is x tends to infinity. The numerator and denominator have the same power. So the answer will be the coefficient of the highest power. Now, if we go by the same logic over here, it is x tends to infinity. This is also linear on numerator and denominator. So the answer is the ratio of the coefficient of the power, and that is 4 upon 2, that is 2. So if you ask me what is the highest power of the numerator, the answer will be 1. It is just x. And what is the highest power of the denominator? That answer would also be 1. So if you go by the logic, the answer to the question will be 5 upon root of 4, which is 5 upon 2. That will be the answer. But then we will show it by a regular step. If it is a 2 marker or a 3 marker, then you have to do the steps. So this is 5x upon x and 6 upon x. And this is 4x square upon x square plus 9 upon x square. So this give you 5 minus 6 upon x and 4 plus 9 upon x square. Taking the limit, 5 minus 0 under root 4 plus 0. So the answer is 5 upon 2. So now if I go to the same property over here, and this was one of the criteria, what do you think will happen when m is greater than n? So whenever the numerator m has greater than 4, the answer will be infinite. Okay, so when this power x raised to m will be greater than x raised to n, the answer will be infinite. So let us try one of the question. Max power of x is 3. So this is 1 upon x, this is 1 upon x square, this is 7 upon x cube. So taking the limit three plus 0 minus 0, 0, and that is infinite. So that goes with the logic that when you have m greater than n, the numerator power greater than the denominator power, the answer is infinite. So now we are left with the third possibility. If m is less than n, in this case, you'll get 0 in the numerator. So it will be 0. Okay, so let's try this. So maximum power of x is 3. You will get 0 plus 0 minus 0 and 1 plus 0 plus 0. So the answer is 0. So all that you need to do is, check which condition, and this same can be treated like a multiple choice. So in this question, there is no denominator, like denominator is just 1. So in this case, remember, we have to rationalize. Just x and the denominator. And now if you check, the maximum power for the numerator and denominator is 1. So therefore, we write taking the limit, it is 1 upon under root of 1 plus 0 plus 0. So the answer will be 1 by 2. So what is the meaning of this? This is sum of first n natural numbers. This is also sum of first n natural numbers. And you know that both of this, what does it mean? It is n into n plus 1 upon 2. Okay, that is the sum of first n natural numbers. So limit of n tends to infinity. The numerator can be replaced by this. We get 1 plus 0 over 2. The answer is 2. In question number 10, you have limit x n tends to infinity. It is sum of n cube upon n raised to 4. So what is this? Sum of cubes of first n natural numbers. Okay, so you have to just substitute that term and you will get the answer. And you know that this is a quadratic, so it is going to give you a maximum power of n squared, and there is a n squared. So here the numerator's maximum power will be n raised to 4, which is the denominator's power. So you are going to get the same thing where I told you m equal to n part from the earlier discussion.